Hello, this is this will be Calculus 1 final exam, and this will be application of derivatives section. So on the other video, it was just derivatives. So now we're going to do some applications involving derivatives. Okay, so let's start with question number one. So question one, we have this polynomial of f of x equals x cubed minus 3x squared, and we got to figure out where is decreasing, or where basically f prime of x is less than 0, right? So we got to find the intervals where it's decreasing. So what we first got to do is find our critical values by first finding f prime of x. So the derivative of x cubed is 3x squared. The derivative of negative 3x squared is negative 6x to the 1. Then what you got to do is set f prime to 0 and try to solve for x. So it looks like we could factor out an x, maybe like a 3x, and that gives me x minus 2. And then when you actually solve for x, you get x equals 0, and then x equals positive 2, right? So basically, I just set each equation to 0, and I solved for x. Okay. Now what we're going to do is x equals 0 and x equals 2. We're going to do some test point, and we're going to put it on a number line, right? So smaller number to the left, so our smaller critical value is 0, and our larger critical value is positive 2. And what we got to do is test 1, 2, 3. We got to test three regions. Region 1 is values less than 0. Region 2 is between 0 and 2. And region 3 is next is greater than 2, right? So what we're going to do is plug it in back into f prime, not f, just f prime. So f prime is 3x squared minus 6x, right? So let's test region 1. What's a number less than 0? It could be any number. I'm just going to use negative 1. So when I plug in negative 1 into the f prime, what do I get? Well, I don't really care about the number itself. I only care about the sign. So if I plug in negative 1 and if you do use a calculator, it does spit out a y value. I mean, it spits out a positive 9. Now, I don't care about the number, I just care about the sign. It's positive, so you're going to use a plus. If your final number is negative, you're going to put a minus. So in region 1, it's going to be positive. Okay. Okay. So let's test region 2. I need a number between 0 and 2. So I'm going to use 1, positive 1, and I'm going to put it back in f prime of 1. So it's going to be 3 times 1 squared minus 6 times 1. And when you put that in, it gives me negative 3. Now, it's a negative, so you're going to put a little minus. Okay. And then let's test region 3. I need a number greater than 2, maybe 3. So when I plug in 3, it spits out 9. And it's positive 9, so you're going to put a plus. Okay, so what is our answer? The problem specifically said where it is decreasing. So you only care, if you go back, you only care about the minus. So that would be in region 2. But how do I write that as an interval? So in an interval notation where it is decreasing, it is going to be from the x value 0 and 2. So you're going to do parentheses 0 and parentheses 2. Why wouldn't I use a bracket? Because we didn't have an uh equal, we didn't have like an equal sign. So so yeah. So this is our answer. Let's move on to So in question two says, here in question two, they give us a graph, and the graph is f of x equals 4 of x. So it would look something like this. I don't know if you can see the different, like the dashed line. There's like a red dashed line here, and then like a rainbow dashed line here. And we gotta, the question says, analyze the concavity. So we got to analyze the concavity. Um, let's see. So is there a concavity up and concave down? Ah, yes, it is concave up. So what is concave up? Something like this, right? This is up, and then this would be down. So I think this region right here is concave up, right? So what would be the interval notation? It's going to be 0, and we're not going to use a bracket. Why? Why parentheses? Because there's like, remember, there's a little red dash line, so it gets really close to 0 but never touches it. And then our largest x value is going to shoot up to infinity, right? So yeah, that's concave up. What about concave down? So this something like this. That would be this area, and I believe that is going to be from negative infinity to 0. Now, let's say you didn't have graph, right? Could we still figure out where, let's say they just gave you the function. Yeah, let's say they just gave you the function f of x equals 4 over x, right? They just gave you the function, no graphs. And they want to know where it's concave up and concave down. So concavity is always second derivative, right? First derivative is related to increasing and decreasing. So what I'll do is 4 over x, I'm going to take the derivative, the second derivative, but I'm not going to leave it as a fraction because it's probably to use a quotient and I don't like that. So how can I rewrite 4 over x as a negative power? I would say 4x to the negative 1, right? So let's find f prime of x. You would have to use the power rule. So negative 1 times 4 is negative 4. And then it's going to be x, and then it's going to be old power minus 1. So negative 1 minus 1 is negative 2. And then let's do second derivative. So negative 2, you would use the power rule again. So negative 2 times negative 4 is positive 8 x, and then old power minus 1, so negative 2 minus 1 is negative 3. And now what we're going to do is set this to 0. So it's going to be 0 equals 8x to the negative 3. And I'm going to write that as negative power, so that's going to be 0 equals 8 over x cubed. And then, so go ahead and get x. Yeah, what would be our critical value? Because if you cross multiply, it's going to give you like 0 clip. It wouldn't be right. 0 equals to 8, which is false. So, did you also know a critical value is also where if you have a rational function, a critical value is also where it makes it undefined. So how do you make this, what are the values that makes this graph undefined? You simply set the bottom to 0 and solve for x. So if you set x cubed to 0, and then if you solve for x by maybe raising everything to the third, you get x equals 0. So yeah, if you have a rational function, your critical value is also where it makes it undefined. Okay, so let's test it. So we have one critical value at x equals 0, so that means we got to test the left side of 0 and the right side of 0. And then we're going to put it in f double prime. So f double prime is 8 over x cubed. Now let's test region 1 and number less than 0, so maybe f, how about -1? So that'd be 8 over -1 to the third. So that's 8, and then -1 to the third is -1, which is -8. It's a minus, so you put a minus. And then let's test region 2. I need a number larger than 0, so maybe I could use +1. So when I do that, let's see, I get 8 over 1 cubed, which is 8 over 1, which is +8, and it's going to be positive. Okay, so concavity, what was the problem they're asking? Where is it concave up and concave down? So minus means down, positive means up, right? So concave down is from -infinity to 0, and concave up is from 0 to infinity. Okay, that's that one. So let's move on to question 3. So question 3 says we have this function f of x equals 9 minus 14 over x. Find all c in the intervals of 2 to 7 such that uh, f prime of c equals f of 7 minus f of 2 over 7 minus 2. So they kind of gave you a hint, and what we're doing is we're trying to we're basically finding the mean value theorem. So what is the mean value theorem? 2 is like your A, uh, 7 is like your B. So it's basically f prime C, uh, f of B minus f of A, all over B, right? So this is basically the mean value theorem. So let's try that. So do we have everything we need? Um, Not quite. So when you put this on, our B is 7, so it's going to be f of 7 minus f of A, which is A, f of 2. And then on the bottom, it's B minus A, so it's 7 minus 2. Let's see. What I'll do is we kind of did the right side already. So 7 minus 2 is 5, but I don't know what f of 7 is, and I don't know what f of 2 is, right? So let's figure that out. So let's find f of 7. So go back to your regular f of x, and wherever you see next, plug in 7. Replace it with 7. So it's going to be 9 minus 14 over 7. Negative 14 over 7 is -2. 9 minus 2 is 7. So you can say f of 7 is 7. And then let's plug in f of 2. It's 9 minus 14 over 2. So it's 9. And then 14 over 2 is 7. So minus 7. 9 minus 7 is 8, 9. 8, 9, 2. Okay, so 7 minus 2 is 5. So it's 5 over 5, which is 1. Now, let's do the left side. It's f prime of c, because our goal is to find c. So let's do that. So if we're given f of x equals 9 minus 14 over x, I'm going to rewrite that as a non-fraction. That's the same thing as 14x to the -1. And then go ahead and find f prime of x. The derivative of 9 is 0. The derivative of negative 14 to negative, so negative 1 times negative 14, positive 14, x, and then old power minus 1, so negative 1 minus 1 is negative 2. And if you kind of clean this up, this is 14 over x squared. And then just plug in c for x. So that gives you 14 over c squared. Go ahead and cross multiply. So c squared times 1 is c squared equals 14. Take the square root. You get c equals square root of 14 and positive 14. So if we can only go from the intervals 2 to 7, I think we can eliminate negative square root of 14. Okay. Wait, hold on. What did I just do? So I found f prime, which is 14x to the negative 2, and then I replaced the x with c. So f prime of c is 14 over c squared. And then I set that equal to this side, which is 5 over 5 or 1. And then I cross multiply. Okay, there I go. So this is going to be 14 equals 1 times c squared is c squared. Take the square root of both sides. Get c equals positive square root of 14 and negative square root of 14. And you can eliminate negative square root of 14. Why is because we can only go from the intervals 2 to 7. So my C value is C is square root of 14. Let's move on. So let's start with 4. So if f of x equals the absolute value of x minus 3, for what values of x is the function increasing? So basically, they want you to find where f prime of x is greater than 0. So or you could just, I think you can get away with just looking at a graph, putting this in Desmo or drawing the graph. Well, how does this graph look like? This is not a bad graph. It's an absolute value of x minus 3. And what that means is there's a horizontal shift of 3 units to the right? So if you want to draw that, that's fine. So here's the x value 3, and it's gonna look like this. And where's the value increasing? So over here, this is going uphill, and then over here it's going down. So where is it increasing in this region, right? So it's increasing from 3, parentheses 3, to infinity. Okay. Okay, let's move on to 5. Okay, so number 5 says f of x equals negative x squared plus 12x minus 34. has a relative min at the x value 6. Analyze f prime of x. Um, so basically what they want is the coordinate for the relative max, right? So here, let's go over this. You could put this in Desmo and find the relative max, but if you want to do it by hand, first what I would do is figure out the critical values. So first you got to find f prime of x. And this is not too bad. You just use the power rule. So starting with negative x squared, that would be the derivative of that would be negative 2x to the 1. The derivative of 12x is positive 12. The derivative of a constant is 0. Okay. And then what you're going to do is set this to 0, the, the f prime, and then go ahead and solve for x. So you're going to subtract 12, you get negative 12 equals negative 2x. And then solve for x by dividing both sides by negative 2. And you get x equals 6. So that's our critical value, and then you put it on a number line. We only have one critical, so you could put 6 right in the middle. So you have to test the left side of 6 and the right side. And then just put it at prime. So f prime is negative 2x plus 12. Okay, so all you got to do is test region 1. A number less than 6, it could be 5, 4, 3, 2, negative. Just going to be 0. So it's negative 2 times 0 plus 12, and that is 12. And I don't care about the number, just the sign. 12 is positive, so you're good with plus. Let's test region 2. I need a number larger than 6, so maybe 7. So when we put that in, that's 2. Okay. So negative 4, oops. This is the minus 2. So negative 14 plus 12 is minus 2. And it's a minus, so you're going to put a little minus. Okay. Um, this is how I know you have a relative max at the x value 6. So how do I know? Because look at the signs. We have a positive to a negative. So if your sign chart goes from a positive to a minus, it's a relative max. Now, if your sign goes from a negative to a positive, you have a relative min. Okay? But they want to know what is the actual coordinate of this relative max. So what you're going to do, we found the x coordinate, which is 6. Now, how do you find the y coordinate? All you got to do is plug that back into your regular f of x. So don't put it in f prime. Put it in regular f of x. So f of x is uh, negative x squared plus 12x minus 34. And then just go and plug in 6. What is that? It's just about 2. So you have a relative max at 2. That does make sense because if you kind of graph it, this graph is a upside down parabola, right? It would look something like this, and then it's like concave down. So yeah, this makes sense. This is your relative max at 6.2. Okay, good. Let's move on to 6. So question 6, we have f of x equals e raised to the negative x squared. We gotta find the max point. So I think all they're asking is it's the same thing as a relative max. So step one is we're gonna have to find the critical value. So step one. So find f prime of x. How do I take the derivative of e to the negative e raised to the negative x squared? It's basically itself, right? Times the derivative of the exponent. So what is the derivative of negative x squared? It is negative 2x. And then you set that to 0, so it's going to be 0 equals, this first, so it's going to be negative 2x e to the negative x squared. And go ahead and solve for x. So what you could do is you could set negative 2x to 0 and then e to the negative x to 0. So if I do that, that's going to be negative 2x equals 0, and then e to the negative x squared equals 0. And then when you solve for x, you're going to divide this by negative 2. You get x equals 0. Over here, I don't think this will work. Yeah, I think this won't work. I think this is undefined because e to the negative x is the same thing as 1 over e to the x squared equals to 0, number 1, and then if you cross multiply, it's 1 equals 1 equals e to the x squared times 0 is 0. This is a false statement. 1 is not equal to 0. So I think our only critical value is x equals 2. I mean, x equals 0. Okay, step 2 is putting it on a number line. Our only critical value is x equals 0, and we got to test the left side and the right side, right? Mm, And we're going to put it in f prime of x. So f prime of x is negative 2x e to the negative x squared. And let's test a region 1. So a number less than 0 would be negative 1. So when you put that all together, negative 2 times 1 to the negative 1 squared. That gives you negative 1, 0.735, right? And that is positive, so you could put a little plus. Region 2, I need a number larger than 0, so maybe 1, positive 1. And that gives me negative 0.735. It's a negative, so you put a little minus. What are they asking? Maximum point. So we do have a relative max at the x value 0 because if you look at the sign, you have a plus and a minus, so you do have a max. And then what we're going to do is find the y coordinate because a relative max has an x and y coordinate. So we know that our x value is 0. What is the y value? So you just simply got to put it back into your f of x. And that gives you 1 over e to the x squared. And then all you got to do is replace that with 0. E to the 0 is 1. So 1. So you have a max point. At 0, comma 1. Okay. Okay. This one says number 7 says find all points of inflection at f of the polynomial f of x equals 2x times x minus 4 to the third. How do you find when you're dealing with inflection point and you don't want to graph it? What you would have to do is inflection point related to second derivative. So first you got to find f prime and then f prime of x, and then you find your critical values by setting that to 0 and then solving for x. And then once you have your critical values, put it onto the number line, and then you have an inflection point wherever the x value signs changes. It doesn't matter if it goes from a positive to a negative or a negative to a positive. As long as there's a sign change, you have an inflection point. So let's first do this. How do I first find f prime? Uh, what rule? Yeah, it looks like the product rule. This is your f, this is your g. So if you recall, when you have two things that are multiplying, you're going to use the product rule. It's going to be f prime of g plus g prime of f. So what's our f and our g's? My f is 2x, and my g is going to be x minus 4 to the third. Okay, so f prime is going to be 2. G prime is going to be, so how do I take the derivative parentheses x minus 4 to the third? You use power rule, so it's going to be 3x to the minus 4, and then whole power minus 1, so 3 minus 1 is 2, times the derivative of the inner parentheses, which is 1. So that's going to be 3. Okay. Go ahead and put it in the product rule, so f prime is 2, g is x minus 4 to the third, plus g prime, which is 3 x minus 4 squared, times it by f, which is 2x. And to save you, when you do the algebra, this is what you get. F prime of x is equal to 2 parentheses, uh, 2 brackets, parentheses, x minus 4 square times 4x minus 4 parentheses bracket. Okay, so that's my f prime. Now, what I'm going to do is find my f double prime. Um, Would I do this? Again, product rule. You have two things that are multiplying. You forget about this too. I mean, it's still part of a problem. So this is your F, this is your G. So when you do the product rule, then you can distribute that too. So my F is x minus 4 squared. Prime is going to be 2 parentheses x minus 4. My G is going to be 4x minus 4. G prime is going to be 4, right? So I'm going to save you time. So when you do the product rule, this is what you should get. That's 2 parentheses x minus 4 times 6x minus 12 parentheses. Okay. Now, what you're going to do is find your critical values. You can disregard this 2 and this 2 because if you set that to 0, it's a constant, so that just disappears. So all you got to do is set x minus 4 to 0, and then 6x minus 12 equals to 0, right? And when you actually solve for x, F4, you get x equals 4. And over here, if you actually solve for x, you're going to add 12, get 6x equals 12. Divide this by 6. You get x equals 2. Okay. So this one I know you have in, so I know, why did I say you have an, x equals 4 and x equals 2? I know I kind of did this ahead, but basically if you put it in the number line, and then you put it in your f double prime, uh, it doesn't matter what, this was like either gonna be positive, and then this is gonna be minus, and then plus. So the key is it, as long as it signs changes, I already have done this, the sign does change, right? It doesn't matter if it's a positive or minus, or a minus to a positive, as long as the sign changes, you have an inflection point. So that's how you know you have an inflection point at these two x values, x equals 4 and x equals 2. Now, an inflection point is actually on coordinates, so we got to find the y coordinate. So what we got to do is plug in these x values back into your original function. So f of x is equal to 2x times x minus 4 to the third, right? So if I plug in 4, and that should give me 2, I mean 0. And then when I plug in 2, it should give you negative 32. So you have an inflection point, or inflection coordinate at 4 comma 0 and 2 comma negative 32. Okay. Uh, graph A, graph question 8. So graph 8, no, question 8 says graph of f prime shown below. For what values does the function have a relative minimum? So this time they give you a graph, and yeah, so where did you have a relative minimum? Uh, yeah, so let's look at the right side of this graph. This is concave down, and then over here, right in the middle part, this is going positive, and then over here, this is going minus, right? Uh, and then this is concave down. So I remember the sign chart. I think a relative, what is it? A relative min. If you look at your sign chart, I believe it's going to be from a negative to a positive. Do we have this? I don't think so. This is a positive and a minus. So everything above the x-axis is positive, right? Here's the x-axis. Everything above is positive, and everything below the x-axis is negative. So I don't think we have a negative to a positive, so I'm going to say the answer is none. Okay, let's move on to the next one and just trying to figure out how much. Okay, next one. Oh, so much space. So number nine. So number nine says find the absolute minimum value of f of x equals x cubed minus 3x squared plus 12 on the intervals -2 to 4. So the key word is absolute minimum. So if you ever hear the word absolute min or absolute max, it's a little bit different from um it's a little bit different from what's the other one? I forget what it's called. It's different from the uh relative min or relative max. That's yeah, it's a slightly different. So when you're dealing with absolute, if they're asking for absolute values, what you're going to do is well, the process is very similar. So the only thing is like you don't do the number line, but first you do got to check for critical values and endpoints. So do check for critical numbers and endpoints, right? So how do you find your critical values? You set f prime of x. So these are easy. So the derivative of x cubed is 3x squared. The derivative of -3x squared is -6x to the 1. The derivative of 12 is 0. And then set that to 0. And then you're gonna like solve for x. So uh it's 3x, and then this is gonna be x minus 2. Set this to 0, and then 3x equals to 0, and then x minus 2 equals to 0. And when you solve for x, you're gonna divide this by 3. X equals 0, and then up here you're gonna add 2, x equals 2. Okay, so these are our two critical values, and can we keep in mind we're only going from -2 to 4. So this is also part of our critical values. Is there if we're going from -2 to 4, can we got to be careful. Can we include these two values? Should we exclude? Does 0 go 0? Does the x value 0 and 2 goes within our boundaries of -2 to 4? Yes, right? So now what I'm going to do is we can use the x value 0 and 2 with the additional -2 and 4. So be care don't worry about this 4 is not a y, it's still an x value. So what you're going to do next is plug in your critical numbers and endpoints in f of x. Okay, so you're going to make a table. And we're going to use the x value 0 because that's part of our critical value. And we're also going to use the x value 2. And then we're also going to use we said it was bounded from -2 to 4. So we can use these are also our critical values or our x values. So we got to find the absolute minimum. So our function is f of x equals x cubed minus 3x squared plus 12, right? So let's plug it back in. Let's plug in our x values. So let's start with f of 0. 0 minus 0 plus 12, that's positive 12. When you plug in 2, you get 2 cubed minus 3 times 2 squared plus 12. That spits out 8. And if I plug in negative 2, that gives me a negative 8. And then when I plug in 4, it spits out 28. So what is the question? The absolute minimum. So of these y values, what is the smallest y value? Yes, negative 8, right? So this concludes that your absolute min is from the coordinate negative 2, negative 8. Okay, so yeah, that is my absolute min. So it's a slightly different process when they say relative min, relative max. You make your critical values, do the number line, and then follow the sign chart. With absolute min or absolute max, you do find your critical values, and then you put it on a table, and whatever the highest y value is your absolute max, and whatever the lowest y value is your absolute min. Okay, let's move on to 10. Okay, number 10 says find the value of C that satisfies the mean value theorem for f of x equals 6 over x minus 3 on the intervals 1 to 2. So what is the mean value theorem? We kind of did that one on a previous problem. MVT, that is abbreviated as mean value theorem, is basically this. F prime of C is equal to f of B minus f of A all over B minus A, right? But before you can even use the mean value theorem, you got to satisfy some conditions, right? First, you got to check if it's first you got to check if it's continuous at x equals 0, meaning there's no gaps or picking up your pencil. Um, I mean, first you got to check if it's continuous everywhere. It's not by so, but they specifically said 1 to 2, so we have to make sure um this graph is continuous from the boundaries 1 to 2. So yes, we are good. If you put this in Desmo, what would that look like? It would look like some kind of rational function, right? But it is continuous because there's no picking up. So we definitely can use the mean value theorem. So let's find that. So we are going from 1 to 2. 1 is your A, 2 is your B, and we're going to plug that back in. So over here, B minus A, so it's going to be 2 minus 1, and then it's going to be f of B, f of 2, minus f of A, and then it's f prime of C. So let's figure the left side. If f of x equals to 6 over x, maybe that's the same thing as 6x to the negative 1. Find f prime of x. So that's going to be negative 1 times 6 is negative 6x to the negative 2, and then the derivative 3 is 0, and then plug in C, right? So x to the negative 2 is like C squared, right? Okay. So now what I'll do is like find f of 2 and f of 1. F of 2 is going to be 6 over 2 minus 3. 6 divided by 2 is 3 minus 3, which is 0. And then f of 1 is 6 over 1 minus 3. So 6 minus 3 is 3. So you get -6 over c squared. And then we said f of 2 is 0 minus f of 1 is 3. And then on the bottom, 2 minus 1 is 1. Okay, and then solve for c. So 0 minus 3 is -3. And you get -6 over c squared. And then you go ahead and cross multiply. So this is going to be -3c squared equals to -6 times 1 is -6. Solve for c by dividing both sides by -3. You get c squared equals to 2. Solve for c by taking the square root. So you get c equals positive radical 2 and c equals a negative radical 2, right? Um, can we use both of those x values? No, we can't include c equals -2. Why? Is because our interval is from 1 to 2, right? So this concludes that our c value is square root of 2. Okay. Okay, give me 1 second. Copy that down. Okay, I'm back. So c is square root of 2. So let's move on. Okay, let's move on. Let's move on to number 11. Okay, so number 11 says particle position is xt equals t squared minus 6t plus 5. For what values of t is the particle at rest? So what does that mean? So they give us xt. So basically what they're doing is we got to figure out when velocity is 0. So it's how do you find velocity? To find velocity, you must take f prime of x, or in our case, it's x prime of t, and then you set that to 0, and then that'll give us your time. So let's do that. So let's find x prime of t. Pretty simple. What's the derivative of t squared? It is 2t. What's the derivative of -6t is -6. What's the derivative of 5 is 0. And then you set that to 0. Solve for t by adding 6. Adding 6, you get 6 equals 2t. Divide this by 2, get t equals 3. Okay, let's move on to 12. Is that all they're asking for? Yes. Okay, number 12 says, equation of a line of tangent to y equals x cubed plus 3x squared plus 2 at its point of inflection. So when they say equation, they want the equation of a line that's tangent to that. We automatically have to use the point slope form. So I believe we have to use this formula, y minus y1 equals to m times x minus x1, right? So what we need is a point and a slope. So so what we need is, when I say point, we need the point of inflection. Because yeah, That's part of the problem point of inflection. So we need a point of inflection. And we got to find slopes. So basically, you got to find f prime. So what should we find first? Let's find the point of inflection. So how do you find point of inflection? You basically take the second derivative, set that to 0, and solve for x. So y prime, so y is x cubed plus 3x squared plus 2. So y prime is going to be 3x squared plus 6x. And then y double prime is going to be 6x plus 6. Okay, and then you set that to 0 and go ahead and solve for x. So just subtract 6, divide this by 6. And we get x equals -1. Uh, okay, so this is we need a point, an actual point. This is only give us the x coordinate. So how do you find the y coordinate of the point of inflection? You simply plug in -1 back into your original function. So plug in -1 into your original function. You get -1 to the third plus 3 to the negative 3 times -1 squared plus 2. And it spits out 4. So your point of inflection is at -1, 4. Okay. And then what now? So what now we got to do is find, in order to find the equation of the line tangent, we got to find slope. So how do we do that? You simply plug in y prime. So y prime was 3x squared plus 6x. And I think all we have to do is plug in our x value -1 because we don't have a y. So just plug in your x value -1. And that spits out -3. So that means my slope is -3. So we have a slope at -3. We have a point of inflection at -1, 4. So we can just put it back in, put it in the point slope form, right? Okay, so it's y minus y1 equals m times x minus x1. Okay, so the point was -1, 4. My m was -3. So it's going to be y minus y1, just 4, and my m is -3. And then it's x minus x1, which is -1. So when you put it all together, you get negative y minus 4 equals to -3 times, and then two negatives become positive, so that's x plus 1. Okay, let's move on. Okay, 13 says, f of x equals 3x cubed minus 5x to the fourth, x coordinates of the point inflection must change sign. Oh, so they're asking what is the x coordinate of the point of inflection. So point of inflection is related to your second derivative, and you know you have a point of inflection if it changes signs. It doesn't matter if it's positive or negative, etc. So first, what I'm going to do is first find my critical values. So first I got to find f prime of x. So what's the root of 3x cubed? It is 9x squared. What's the root of -5x fourth? It is -20x cubed, right? Power rule. Yes. And then let's find f double prime. The derivative of 9x squared is 18x. The derivative of negative 20x cubed is minus 60x squared. Okay. And then you set that to 0. You get 18x minus 60x squared. Set that to 0. And then I guess you could factor out a 6x. And this is going to be 3 minus 10x equals to 0. And then this is going to be 6x equals 0. And this is going to be 3 minus 10x equals 0. When you actually solve for x, you're going to get x equals 0. And then this is going to be x equals 3/10. Okay. Go ahead and put it on the number line. Smaller number is 0. Larger number is 3/10. And you gotta test, you gotta put that in f double prime. I kind of did this, oh, so this is region 1, region 2, region 3. Yeah, I kind of did this ahead. So if I for region 1, I use the x value -1. So we make sure we put it in f double prime. So region 1, a number less than 0 is -1. So that gives me like -78. So that's a minus. Region 2, a number between 0 and 3/10. I'll use +1/10, which is positive. Positive numbers, put a plus. Region 3, any number larger than 3/10. I could have just done 10. That gives me negatives, put a little minus. So you definitely have a point of inflection at the x coordinate 0 and 3/10. Why? Because the sign changes. It doesn't matter what it changes as long as it changes. So it went from minus to a positive to a positive to a minus. So they just want the x coordinate, not the actual point. So you could say x coordinate. X equals 0 and x equals 3/10. Okay, good. Let's move on to 14. 14 says let f be defined and continuous on the closed interval from a to b. If f has a relative max at c and a is less than c is less than b, which of the following must be true? So is it Roman numeral, whoops, shoot, 14, sorry. So let me just reread it again. Let f be let f be defined and continuous on the closed interval a to b if f has a relative max at c and a is less if c is between a to b. Which of the following must be true? Is it Roman numeral 1, where f premise c exists, or is it Roman numeral 2? If f premise c exists, then f prime if c equals 0, or is it Roman numeral 3? If f prime of c exists, then f double prime of c is less than or equal to 0. Uh, so you can, let's try Roman numeral 1. Does F prime of C exists? Yes, because that's like the mean value theorem. So Roman numeral one definitely works. What about Roman numeral two? If F prime is C, this is one C. If F prime is exists, then F prime of C is equal to zero. That is not always true, right? Sure it can be equal to zero, but not always true. So you can forget about Roman numeral three. I mean two, and then is it Roman numeral three? If F primacy exists, then F double primacy is less than or equal to zero. So let's see. Let's say you have a graph like this. Here's your A, here's your C, and here's your B. Here's C, and then it's like a yeah, it's like concave down, like a absolute value. Yes, I do believe the C must be less than or equal to zero. Um, so let's pretend this is an absolute value. Yes, you have an undefined slope. So that means the max of the slope is f prime of x changes from positive to negative. So yeah, Roman numeral three would work. Okay, 15. Okay, 15 says if f of x equals 4x cubed minus 8x squared plus 1 on the intervals -1 to 1 has an absolute value at the x value of what? Okay, so they're asking for absolute values, so we got to make that table, and we're going from -1 to 1, so these are both x's. So first we got to find our additional critical values. So first you got to find f prime of x, which is the root of 4x cubed is 12 squared. The derivative of -8x squared is -16x. The derivative of 1 is 0. Then you set that to 0. And factor out of 4, I guess. So it's going to be 4x times 3x minus 4 equals 0. And then when you actually solve for x, you're going to get x equals 0, and then x equals 4/3. We'll go ahead and make a table. You get x and then your y, or you say f of x. So our critical values were 0 and 4/3. Can we use those? Yes, we can use because -1, our interval is from -1 to +1, right? So we definitely can use the x value 0, and we definitely can use the x value 4/3. And then these are also additional x values. So -1 is also an x value, and +1 is an x value. So the question is saying, what is the absolute minimum at the x value? So what is the smallest y coordinate? So put it back into a regular f of x. So let's plug in 0. So when I kind of did this in my work, so but if you could put this in the calculator, so f when you plug in 0, it spits out 1. When you plug in 4/3, it spits out negative 3.74. And when you plug in -1, it spits out -11. And then when you plug in 1, it spits out -3, right? So they're asking you what is the absolute minimum. So of these y values, which one is the smallest of the smallest? -11. So your absolute min is from -1 to -11. Okay, let's move on to 16. 16 says find the value of c that satisfies the mean value theorem on the intervals 0 to 5 for the function f of x equals x cubed minus 6x. Okay, so this is like the mean value theorem. So find the value of c so it's at that. So find the value of c that satisfies the mean value theorem on the interval 0 to 5, where f of x equals x cubed minus 6x. So mean value theorem. So it's going to be f prime c is equal to f of b minus f of a all over b. Say 0 is for a, 5 is for b. Okay. Let's just know what we know. So on the bottom here, what's b minus a? So if b is 5, it's 5 minus 0. And then f of b, so f of 5 minus f of 0. And then what is f prime of c? So let's find f prime of x. It's going to be 3x squared minus 6. And then f prime of c is 3c squared minus 6. So what is f of 5? F of 5 is going to be 5/3 minus 6 times 5, which is, I think, 95. F of a, or f of 0, still 0. So it's 95 minus 0 is 95. And then 5 minus 0 is 5. And then on the left, you have 3c squared minus 6. Okay, so 95 divided by 5 is 19. And then you have 3c squared minus 6. And then you add 6, add 6. You get 3c squared equals 19 plus 6 is 25. 3. You get c squared equals to 25 over 3. Solve for c by taking the square root. This is the same thing as square root of 25 over square root of 3. Square root of 25 is 5 over square root of 3. Rationalize the denominator. Can we use the negative c value? I don't think so because our interval is from 0 to 5. So that means our c value is this. Let's move on to 17. So 17 says the maximum velocity attained on the intervals from 0 to 5 by the particle whose position is given is s of t equals 2t cubed minus 12t squared plus 16t plus 2 is. So they're asking for maximum velocity. So do here. Yeah, so we're gonna make a table. It's not asking for this is like an absolute minimum, absolute max problem. So it's just like the one above, 16. So we're going from 0 to 5. So these are your x values as well. And what we need to do is first find our critical values because we got to find v prime of t, which is a of t, and blah blah. Hold on. So what did they give us? They gave us s of t, which is 2t cubed minus 12 t squared plus 16t plus 2, right? And then what we're going to do is find vt by taking the first derivative of this. So this is going to be 2t cubed is 6t squared. The derivative of negative 12t squared is negative 48t. The derivative of 16t is 16. And then you got to find a prime of t, which is a of t. So what's the derivative of 6t squared, 12t? What's the derivative of negative 48t, negative 48. And then you set that to 0. And we go in and solve for t. And 8 by 12. And we get t equals to 4. So if you make our table, this is your t and this is our v of t. Okay. So so this is our VT right here. So be careful. So we're going from, what is it, 0 to 5. So we're going to do 0 and then 5. And then we're also going to use 4 because that's part of the critical value. So be careful. We're putting 0 into v of t. So this one right here. And when you plug in 0, it should spit out 16. And then plug in 5 into v of t as well. When you plug in 5, it spits out negative 80. And then when you plug in 4, it spits out negative 74. Okay, so what are they asking? Maximum velocity. So the largest y value is 16. So maximum velocity is at 16 meters per second. Okay, let's move on to 18. So 18 says, which has a relative max? So what is a relative max? So if you look at your sign chart, a minus to a positive is a minimum. And then from a positive to a minus is a max. So if they're asking for a relative max, we got to follow this sign from a positive to a minus. So let's look at graph one. So when you're going downhill, it's a minus, and when you're going uphill, it's a plus. So uh, let's look at graph one. So over here, you're going to minus, going downhill, and then you're solidly going up. And then this is also a plus, and then this is a minus. So I think it's this one because this one has a max and a min, so the graph one has a relative max. Oh, relative max. Yeah, so if you have a max and a min, that means it has a relative max. So this is going to be this one because this has a max and min, right? So according to the rule, so this set, if you have a max and a min, that means you have a relative max. So you have max here and a minimum there. So this has a relative max. Okay, so that's why it's graph one, and then we could exclude the other graphs. Okay, so let's move on to the next one. Okay, 19 says point on the curve 2y equals x squared to the nearest to the point 4 comma 1 is what? So what is the point on the curve of the graph 2y equals x squared is nearest to 4 to the point 4 comma 1? So when they say that, we're gonna have to use the distance formula, right? Or you can try to graph it. So I'm gonna use my distance formula. So distance formula is square root of x2, x subscript 2 minus x subscript 1 square plus y2 plus y1 squared, right? And my x value is 4, my y value is 1. So that means it's going to be d equals square root x2, which is x, minus x1, which is 4, square plus y2, which is y, minus y1 is 1. And then what? Then what we're going to do is find this y, because we got to put it in terms of x, right? Because we want to solve for x. So we were given 2y equals to x squared, right? So if you try to solve for y, you're going to divide this by 2, and you get y equals x squared over 2. Okay? So it's going to be d equals square root of x minus 4 squared plus, and then y is x squared over 2 minus 1 squared. And then what you're gonna do is you're gonna square both sides because we want to get rid of the radical, right? So go ahead and square both sides. So on the left, it's going to be d squared. And then on the right, when you square this, the radical disappears. You're left with x minus 4 squared plus x squared over 2 minus 1 squared. And then what you're going to do is take the derivative of both sides. So, take the derivative in respect to x. So on the left side, the derivative of d squared in respect to x would be 2d, and then you're going to add a dd over dx, right? Implicit differentiation. We put a d on the top because this is what the letter we're given. We're going to put a dx on the bottom because that's what we're taking it in respect of. And then over here, x minus 4 squared is going to be 2 parentheses x minus 4 to the power of 1. And you don't have to do that dx over dx because it cancels. Same thing here. This is going to be power rule, so it's going to be 2 parentheses x squared over 2 minus 1. X. So what happens now is you want to solve for dd over dx. So on the right side, go ahead and FOIL this out. So this is going to be 2x is 8. And then when you FOIL and clean this up, you're going to get x cubed minus 2x. And the 2's cancels. And now you're left with x cubed minus 8. And then you set that to 0. Add 8, add 8. And then you get x equals 2. Now we want a point, so we got to find the y coordinate. So how do you find the y coordinate? We also said that y equals x squared over 2. So to find y of 2 is going to be 2 squared over 2, which is 4 over 2, which is 2. So this concludes that the point 2, 2 is the closest point. Okay, let's move on. So number 20, so 20 is a word problem. Uh, okay, we only have 2 more word or 22. Okay, yeah, 2 more word problems and then we're done. So on this word problem says the volume of a cylindrical tin can with the top and bottom is to be 16 pi cubic inches. If a minimum amount of tin is to be used to construct the can, what must be the height in inches of the can? So yeah, so the volume of let me repeat it again. The volume of a cylindrical tin can be with the top and bottom is to be 16 pi cubic inches. If the minimum amount of tin So the smallest amount of tin is to be used to construct this can. What must be the height in inches of the can? So if you want, you can like draw the can. And we get this. And this is your height. And then the volume is, they tell you the volume is no larger than 16 pi. And we know that the volume of a cylinder is also pi r squared times h. And what we'll do next is we're going to replace v with 16 pi, that's given. And then I'm going to get rid of this pi by dividing both sides by pi. So you get, whoops, you get r squared h, and then the pi's cancel, so we're left with 16. And so what we're trying to do is like, when you make this can, it's actually just a rectangular piece, right? Um, so you have this rectangular piece, and we know that the circumference is 2 times pi r, and we need to find this height. So what else, what other formula shall we need? We need to find the surface area. So surface area is also 2 pi r squared plus 2 pi rh. And then what I'm going to do is, from this formula, I'm going to find h. So we have 16 equals r squared times h, solve for h by dividing both sides by r squared. So you get h equals 16 over r squared. And let's see, so that's my h. Then we're going to put it back into this formula right here, surface area. So surface area is equal to 2 pi r squared plus 2 pi r, and then we're going to replace h with 16 over r squared. Okay, so that means if you clean this up, you get SA equals 2 pi r squared plus 2 pi rh times 16 over r squared is going to be 32 pi over r, right? Then what you're going to do is take the derivative of this in respect to r, but I have a fraction. I'm not going to write it as a fraction. I'm going to just say 32 pi over r is the same thing as 32 r to the negative 1. So it's going to be d SA over dr. The derivative of 2 pi r squared is 4 pi r. And then the derivative of 32r to the negative 1 is negative 32r to the negative 2. You get 4 pi r minus 32i over r squared equals to 0. And if you add this to the right, so if I add 32 pi over r squared. Get 4 pi r equals, so 32 pi over r squared. And then our goal is to solve for r and h, so cross multiply. So when you cross multiply, we're going to get r cubed equals 32 pi over 4 pi. The pi's cancel, so you're left with r cubed equals 8, and then r equals 2. And then over here, yeah, we need to define that r because now we can find our h. So if you recall, h was also expressed as 16 over r squared. So that means it's going to be h equals 16, and then r is 2 squared. And that's 16 over 4, which is 4. So my h is 4. Okay, let's move on to the next one. Okay, 21 says a farmer has 160 meters of fence to enclose two adjacent rectangular pig pens. What dimension should be used for each pig pen so that the enclosed area is a max? So a farmer has exactly 160 meters of fence to enclose. And it's somehow made into two pig pens. What is the dimension should be used for each pig pen so the enclosed area is a max? So imagine, here, let me draw the image. You have this little rectangular pig pen, and it's broken into two pig pens, right? You have two adjacent rectangular pig pens, and the perimeter is 160, and we got to find the dimension. So we got to find, let's say this dimension is x, this dimension is x, this dimension is y. So it looks like two squares, and squares, all sides are congruent. So this would be x as well, x, and then this would be length y, and then this length here would be y. So we know that the perimeter is 160, or you could think of it as adding up all the sides. So if you add up all the side lengths, what do you get? This would be 1x plus 1x plus 1x plus 1x, that's 4x. And then 1y plus 1y plus 1y, that's 3y. And you get perimeter is 4x plus 3y. And then what else do we know? What about area? What is an area? It is length times width. So the area is so look at the area of pig pen 1, pig pen 2. The area of this pig pen is xy, and the area of this pig pen is also xy. The total area is 2xy. So we got to somehow find, it says what are the dimensions should be used for it. So basically we got to find x and y. So we have a perimeter equation that's 4x plus 3y, and then we also have an area equation that's a equals 2xy. So that means is let's use the area formula. So area equals 2x, and then let's replace y with what? What can we replace y with? All right, let's replace x. So we'll use area, and then I'm going to replace x with something. What should I replace x with? This formula. So if per meter equals 4x plus 3y, and then the total per meter is 160, so it's going to be 160 equals to 4x plus 3y. And somehow let's solve for x. So I'm going to subtract 3y, subtract 3y, you get 160, 4x, all this by 4. So you get x equals to 40 minus 3.4. So it's going to be 40 minus 3y over 4 divided by y. You get a equals 80y minus 3 half y squared. So then what I'm going to do is take the derivative of this formula, dA dy, in respect to y. So it's going to be dA dy is equal to the derivative of dy is 80. The derivative of negative 3 half y squared is going to be negative 3y. And you set that to 0. We need to subtract 80, you get negative 3y equals 80. Divide this by negative 3, divide this by negative 3, you get y equals 80 over 3. Now, yeah, that y value is going to be, that makes it a max. Now, how do you find the x? So we kind of know what x is this one right here. We know, we'll just plug that back in, replace y with 80 over 3. And we do all the algebra to get 20. So our x is going to be 20, and then our y is going to be 80 over 3. Okay, let's do one more like this, and then we'll end it here. So 22 says, a rancher has 100 yards of fencing as seen in the figure below. All three pens have the same width x. Which value of y produces the max total fence area? So, did I draw the image? No, I did not. Let me show you the image. It should look like this. Okay, so this is the image that was given. So let me reread the problem. A rancher has 100 yards of fencing as seen in the figure below. All three pens, so pen 1, pen 2, pen 3, all says all three pens have the same width of x, which value of y produces the max total fence in the area. So we're gonna solve for y that gives a max area. So what do we know? We know the total perimeter is 100 and perimeter is adding up all the sides. So if you add up all the x's and all the y's, you have 1x, 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 2. This is also x, right? So 1, 2, 3, 4, 5. So you have 5x. Then all the y's are 6y. So this is a y, this is a y. So when you add up all the y's, this should be 6y. Okay, and then what you're going to do next is replace y with 100, because that was given. And what else? Let's do area. So what is the area is basically length times width. So the area of one, so area of one, this one right here, this pig pen is xy. The area of this pig pen is also xy. The area of this pig pen is 2xy, right? The length is, yeah, 2xy. So the total area is going to be 4xy. So I'm going to circle this. We're probably going to use this. We're probably going to use this formula, right? So with the area formula, so I gotta find x and y. So what I'm gonna do is use this equation, this perimeter equation, and I'm gonna solve for x. So when I do that, it's gonna be 100 minus 6y equals to 5x. And then you divide this by 5. X equals 20 minus 6/5 y. And then what I'm gonna do is I'm gonna use the area formula, right? And then I'm gonna replace my x with 20 minus 6/5 y times it by y. And then I get area equals to 80y minus 24/5 y squared. Then what I'm going to do is I'm going to set a to 0. It's going to be 0 equals to 80y. No, no. Then I'm going to take the derivative of these terms. So the derivative of 80y is 80. The derivative of negative 24/5 y squared is negative 48/5 y. We're going to set that to 0. And then I'm going to subtract 80. And when you actually solve for y, you get y equals 400 over 48. Now, how do you solve? Because wait, what are they asking? They only want they're asking for the y, so that is your final answer. Okay, that was the last problem for derivative section, and then there should be an integral section. So I'm going to stop right here.